Sounds good. Like Becca said, my name is Callie Alton. I'm one of the customer success engineers here at Amper, and today we're going to go over some of the 8 wastes that you can see in manufacturing. So the agenda for today, we're going to do an overview. We're going to cover the 8 major wastes, look at next steps, and then we'll have it open at the end for Q&A. But like Becca said, if you have questions throughout while I'm going today, you can raise your hand or you can pop it in the chat at any time. So as an overview, when it comes to the lean manufacturing method, there's 3 main wastes that we can look at. And these can be categorized as MURI, overburden, MURA, unevenness, or MUDA, physical waste. These branch off from the Japanese Toyota lean manufacturing system, and kind of how these look. When you're looking at the overburdenedness, it's one person taking on too much to handle. And then you have MURA, unevenness, fluctuation, variation, where one person is taking on more than another. This can also look like bottlenecks in your system if it's holding up the next stage in the process. And then finally, we have MUDA, which is the physical waste. Not enough people are doing up to the capacity that they're capable to. We want to strive to have no MURI, MUDA, or MURA, which is going to be the most evenness we can do. Looking specifically at MUDA, the physical wastes, we can break these down into 8 major categories. An acronym for this is going to be downtime. You're going to have defective production, overprocessing, waiting, non-used employee talents, transportation, inventory, motion, and excessive production. So we're going to break these down one by one and look at some examples as we go through. Please feel free to pop some examples you yourself have in the chat. Like I said, you can get a free t-shirt if you're interacting with us. So looking at the first one, defective production, this one's going to be any information, products, or services that are incomplete or inaccurate. A good example for this one is going to be scrap, broken parts, or even missed deadlines as a physical defect in production. I had a customer recently who had a large incident that happened where the operator forgot to measure every 5 parts that they were required to, and caused hundreds of parts that had to be scrapped because of that. So defective production is definitely a large area for waste that can be improved. The next one we have is overprocessing. This is making extra of something, making it earlier or faster than needed. It can also be extra copies of reports, redundant storage, or even hitting reply all on emails can also be considered overprocessing. I don't know if you guys heard, but a few months ago, a team at Microsoft was hosting a luncheon, and they wanted to email their team to let them know about it. Well, they accidentally emailed all 50,000 Microsoft employees, and every time somebody would reply back to that chain, they would reply all saying, "Oh, I don't think this was meant for me." Reply all, "I don't think this was meant for me." So it caused a lot of reply all emails over processing that people didn't need to be on. The next one we have is waiting. This can be waiting for information, equipment, material, parts, or people. Waiting is non-value added, therefore is a waste. It can be for approvals, equipment, or even large batches. This could also be, if you have an operator that's waiting, can be a red flag for a bottleneck in your workflow. The person is waiting for something else prior to that process. The next one we have is non-used employee talents. So this is not properly utilizing people's experience, skill, knowledge, or creativity. This one is harder to, identify and as well as quantify. But one big factor you can see is that you want to make sure your people are trained. When it comes to continuous improvement, that applies to your employees as well. You want to make sure they're always learning and growing. Having good employees that stick around and help grow your business is a big factor. So I have a question from Abby here. Is there a way to get visibility into my people in Amper? So there is. Amper actually has a new feature called labor metrics that I can review here at the end of the slides to show you how that's going to be related to it. But actually, if your operators are logging into Amper and tracking their tally sheet usage, we're able to see how they're operating as far as their utilization, but also we have created a labor metrics and an engagement multiplier to view. I'll pause here and see if anybody has any more questions or examples of these first 4 that we covered. Anything? These were defective production, overprocessing, waiting, and non-used employee talent. I'll go ahead and hop to the next section. So now to the transportation portion for T. Transportation is any unnecessary movement of materials, information, or equipment. This can be transporting materials from your storage onto your factory floor or even between processes. Anytime your product is going to be moving points, it has opportunity to be lost or damaged in that movement. So we want to try to eliminate transportation as much as possible. The I is going to be for inventory, any accumulation of parts, information, applications beyond what is required by the customer. Anything beyond what is required is going to be considered waste, therefore not necessary. This can also be stockpiling of supplies, keeping data or even old equipment longer than necessary. You probably have some old machinery tucked away in the back that you think maybe you might use someday, but it's waste if it's just sitting there and taking up room. You know, when we're looking at inventory, also keep in mind this is going to be anything that's work in progress, anything that you have that's finished goods and raw material as well. M is going to be for motion. So any movement, people, or machinery that is not value added to the customer. This can be in the form of repetitive keystrokes or walking between equipment. Excessive motion is going to cause wear and tear on your machinery to not have it the life expectancy that's expected for it, as well as it could cause injuries to your employees as well. And finally, we have E for excessive production. So any steps that do not add value in the eyes of the customer, extra formatting, extra features, or excessive detail. This is going to go hand in hand with inventory. It's going to increase the chance of anything that comes to defective production whenever you have excess going into it. So reviewing all of these again, we had defects, overprocessing, waiting, non-utilized employee talent, transportation, inventory, motion, and excessive production. Does anybody have any examples of where you see waste in your factory?
The chat is having some problems, but you can drop any comments in the Q&A as well. So use a Q&A feature for questions, comments, compliments.
I see one from Michael. Says, oftentimes what happens at the start and end of our shifts, how can Amper help with this, especially if it's difficult to have bandwidth for a project? So there is a lot of waste when you're looking at how long it takes your employees to get started in the morning, or if they're wanting to stop their machines earlier than needed. Amper has a feature called late starts, early stops, where you can set the expected time that you see for warmups and can track that there. It's going to be a report that can be emailed to you on whatever basis you'd like to get that information. And we can review that as well. There's no more examples. We'll go ahead and move on to the next steps. So now that we've talked about the wastes, how does Amper play into this a little bit more? So we want to help you plan for long-term success with Amper. The first step of that is to get the full picture. You want to understand what's currently happening on your factory floor. For this, Amper recommends starting to do downtime labeling. Our goal for this is for you to have your downtime unlabeled less than 10%. We also recommend you can start using setup tracking and then track your call response times. And here I'll actually exit out of this and I'll pull up the Amper. So this first one is the Amper dashboards for downtime. Whenever your operators enter the downtime reason for why their machine was idle, you'll first be able to see the number of times they've selected this reason. You're going to be able to see a pie chart broken down by the parent reason and sub reason. For these, we'll also break it down for you by date, shift, machine, and even operator. If there's a specific reason that you're wanting to dig a little bit deeper into, if you'll hover over it and select it, it'll filter all the following information down to look at that. So if we wanted to work on a project to reduce this machine crash breakdown, I first want to capture my baseline of how much time is being taken up by this. I'm going to look at the last 30 days. If you wanted to look at a larger data set, you could adjust that to look at the last 90 days or even year to date. We also have custom options. So as I filtered for this parent reason, I also have child reasons related to this. So I'm able to see that of this 761 hours, 717 was due specifically to mechanical downtime, as well as electrical contributed 26 hours, and then general machine crash breakdown was only 16 hours. If I'm looking at this, I know it's hard to really see what picture. So if I scroll down and say, well, what is it a specific shift that's causing these issues? Do I have a specific machine? Here we can see that Mosca 4 has 253 of those hours taken up. So I might need to do some additional maintenance or PM planning for the future on this machine. It could even be a specific part that's causing these issues. When I'm running, is it just a single part that I'm always having to stop on? Do I need to go back and look at the engineering plans and evaluate if they're set up the correct way? So this is just one of our many reports we have. Another one you can look at to see where some waste might be is going to be our call response. So the operators have the option on their tally sheets to call for help with call teams. You would create these call teams yourself, and then you can see how long it's taken to resolve these calls. So right now we have maintenance calls and supervisor calls that have been done since 5/17 and 5/23. Whenever you create these call teams, you also set a target of when you'd like them to respond to these calls. Right now, we can see that maintenance is going over that limit we set and supervisors are under it. If we see here, it looks like Randy's taking a little bit longer to respond to these calls, but we can see that Aaron is hustling to get over and answer the questions that the operator has. If you want more detailed information, you can scroll down and it'll see day by day who's been getting these calls and how long they've been taking to respond on that specific day. So popping back into the slides, once we have gotten the full picture, then we can start eliminating that waste. So after about 3 to 4 weeks of getting all these downtime reasons in, we can start using some tools to assess the problem. So we can do some process mapping to see if there's somewhere along the lines, there's a bottleneck that's holding us up. Your CSEs can work with you to create a spaghetti plot to see if maybe there's something in the layout of your factory that needs attention, or if there's a lot of waste going around as far as inventory, maybe you need to do a 5S project and work on some organizational tools. Once we start eliminating waste, then we can do the continuous improvement, which is just the cycle of always having a project in mind to make things better. You want to pick a project, and this can be done as a team if they're just the high-level executives that want to look at this. If you want to work with your operators and see everything that they have in mind, you can go to a whiteboard and draw this impact effort matrix. You can have all the projects written on sticky notes and put them where they fall here. If you want to start off with a project, we recommend doing one that's going to be an easy win. So this is going to be something that has a high impact to your team with low effort. As you go down the line and you've tackled a lot of those easy wins, it might be time to move towards working something that has a high impact, but also might have a little bit of higher effort involved in that. Some tools you can use while you're working on this is going to be the PDCA, which is the plan, do, check, and adjust. So you're going to plan what project you're going to do. You're going to actually do it and then check to see how it did. And then you can adjust to make any changes that needed to be done as well. We also recommend doing the A3, which is what Ford uses to create their project plan. And we actually, Becca has a blog that we wrote about that as well previously that she can pop in the chat if you'd like to review that.
Yeah. It will be sent in an email afterwards due to the chat malfunction. Apologies.
We have another question that popped up. For aluminum excursion process, in which physical waste is a small percentage of production, but still represents a significant dollar value increasing? What kind of reports tools could help make incremental changes? So I think this also kind of goes hand in hand with Michael's question earlier. A good place to start for this one might be looking at just your late starts, early stops. So under the dashboards, late starts, early stops, we'll be able to see how long it's taking your operators to get going in the morning. It might not seem like a lot, but that time can add up really quickly over all your machines, and it can make a big change in the additional production time that you could have. So in this demo factory we have here, we're able to see the average late start, early stop time is 7 hours and 21 minutes in the last 30 days, and they're stopping 5 hours and 37 minutes earlier. So this is across all the machines. So there could be one that was down for the day that needs to be taken out. But overall, this is how it's going to look. And for all of these reports, you can get them scheduled to be sent to you. So if you click these 3 dots here, you can say schedule for delivery. You can choose to get these kinds of reports sent to you on a daily, weekly, monthly, even a quarterly basis to look at this information. You put the select when you'd like to receive it, the time and day, if that's relatable, and then you put in your email address, save it, and it'll start getting sent to you on that. Another area that might be good for you to look is going to be our executive summary. So this is going to be high level, what's going on in the factory on a day-to-day basis. It's first going to have your utilization percentage as a whole factory, and then broken down by shift. It'll also let you know the downtime reasons for the date that you set it at. It'll also let you know your unlabeled percentage by week. So if that's something you're tracking, it could be good to get this one sent to you on a daily or weekly basis. And then another one that I know we talked about was the labor metrics. So we'll go ahead and pull that one up as well. So this one is going to be under the dashboards, labor metrics. And the first chart you're going to see is the labor multiplier. It's going to have it broken down by operator so you can see how they compare to one another. And this labor multiplier is going to be the up hours that this operator had versus their total paid hours. We're calculating this by taking it from the tally sheets. So when they first logged into a tally sheet, the final tally sheet they did. As you scroll down, you'll also see this nice information that lets you know the operator's name, their total engaged hours, their up hours, paid hours, their labor multiplier, engagement multiplier, and then your utilization for each employee overall, how they've been doing. So as we scroll down, we'll also see the labor multiplier by machine. So this is going to give you valuable information to see how each operator is doing on each machine. Do I have one operator that's running a machine more efficiently than another person? Is everybody running this one machine poorly? Do we need to do some additional maintenance on this? We'll also see up hours versus paid hours by machine, as well as direct time by machine by operator. So if you're expecting an operator to work on just a certain set of machines, you can go through here and see where he's spending his time. Is he working on a machine that wasn't necessarily supposed to be in his job for that day? Do you need to go through and follow up? And then finally, we have your engaged versus paid time per each operator in a bar chart for you to view really how they're doing compared to each other. So any final questions for us today? Myself or Becca would be happy to answer anything you have. We can show you more features of Amper.
Don't forget there are very cool t-shirts on the line. Questions, comments? All right. If you think of any questions after the session, you can always feel free to contact us. Callie, I think if you go to the next slide, we have some info. If you are an Amber customer, contact your CSC if you have any questions, comments, ideas. And for any non-customers, you can also email us at marketing@amber.xyz, and we'll put you in touch with the right person to answer your questions. But yeah, keep an eye out for an email with the recording, with the link to the A3 template, and a code for a free t-shirt if it applies to you. So a few more seconds in case anyone has any last minute questions or comments.
It looks like Say2 wanted to look at the part performance dashboard to quantify a scrap dollar value. I can pull that. So this is going to be under dashboards and part performance. So we're able to see how each individual part is performing compared to one another. To get this information, your operators do have to be using the tally sheets and then entering the part number that's associated to that to add additional part numbers that can be done in your settings. But looking at this information, we first see the uncapped part performance, so how it's doing versus the calculated cycle time that you initially put into Amper. And then here we have the parts performance details broken down. So we have the part number that you're expecting, the target cycle time, and in the last 30 days, how many good parts, scrap parts, and the quality that was run. So your operators do have to be entering their part counts and their scrap, but we do offer automated part count. If that's something you're interested in, you can hook that up to your machinery and Amper can calculate those part totals for you. This will also show you the uncapped part performance by date and then the downtime reasons as well. If you wanted to calculate the scrap value you're losing per part, though, you can go through and see, okay, I'm interested in part 56318 in the last 30 days. How much scrap did I have? What's the value of that material, the cost to me, and multiply that to see how much you've lost in that time period. Thank you for the question. Well, thank you, everybody. I appreciate your time and I hope you have a good rest of your day.
All right. Thanks all.